Okay, thank you everyone for coming early. This is Zohe Basan, the session chair of this online presentation session. Uh, we have a schedule, a sequence of presenters that we already know. I'll show it to you on the screen. We have one of the presenter with us already, but we have to wait because the first presentation that will take place will be optimizing hyperparameter for from Halim Yusufiana and her team. So after that, at about after 15 minutes of that presentation, we'll have Deepa ma'am's presentation and then so on. So the schedule is above, the time schedule is above. It is, yeah, it's this. So from 12:10 to 1:10, there'll be two presentations. And then after a lunch break of 1:10 to 2 p.m., there'll be two more presentations between 2 to 3. So I'll request all of you to wait. Uh, we'll start the session at 12:10. Uh, Welcome, Mr. Halimi. Wait, I'll give you the access to unmute yourself. Yeah, can you hear me? Hello, Mr. Halimi, can you hear me?
Hello, I
Hi.
can hear you.
Yeah, so as per the timing, we'll start at 12:10. And if in case you are ready, we can start now. Are your other team members coming? Will be they be joining?
Is it my turn to presentation or what?
Yeah, yeah. Your presentation is just means your presentation will be the first according to the timing, and the timing schedule was 12:10. So what I'm saying that if you are ready and all your team members have joined, or are they going to join, we can start right now as well because all of our audiences are there, they're online. So if you are ready right now, we can start your presentation.
Okay, I will prepare the presentation now.
Yeah, yeah, yeah. You can start presenting. Okay, all of you, please now pay attention. We have our presenter with us. His topic of presentation is optimizing hyperparameters for advanced deep neural network to predict solar still efficiency. I would request all of you to listen diligently and ask questions if you have any. And you have around 10 minutes and 5 minutes for a question answer session. Thank you. You can share your presentation and start, Mr. Halim.
Okay.
Yes, it is visible.
Please tell me the slides moves or
Yes,
not because I have
your
a
screen.
problem.
Yes, your screen is visible. The thing is that it is it in presentation mode? No. The thing is that you have only shared the PowerPoint window. So when you present it, that presentation won't be visible to us. We can see your PowerPoint slides, but the presentation itself is not visible. Like in the slideshow mode, it is not visible.
Okay,
So
I will keep it like this.
that's okay. That's okay. It is still visible. You can present it like that only. Or maybe can you hide that menu bar from above? It will be more visible. Minimize that toolbar from there. It will be bigger. Right click and minimize that ribbon.
Okay, just a minute.
I think it would work if you right click on it and minimize. It would work if you right click on it or try pressing the home button again, that home menu. If you press again, maybe it will go back. It's not happening. Can you right click, see if there any option comes? Right click on the ribbon somewhere, minimize. Or there's one option you can present your complete screen. You can show your complete screen and then everything would be visible. Sharing entire screen option will come at the very last when you share the screen.
Uh, I don't know how use it.
It's visible. You can start anyway, no problem.
Okay, okay. Thank you. Hello, everybody. I will present my work titled Optimizing Hyperparameters for Advanced Deep Neural Networks to Predict Solar Efficiency. First, we will begin with the introduction and the problematic of the challenges of freshwater supply in arid regions is the main problematic. The supply of freshwater is one of the challenges of the world. The arid regions of North Africa are characterized by scarce rainfall, such as southern Algeria. The exploitation of groundwater, which is non-renewable in the Algerian desert region. Recyclable brackish surface water is not included. The most problem limitation to the use of surface water remain the issues of salinity and contamination. So the proposed solution is to deal with this situation is to use solar energy to drive solar desalination as water treatment systems to compensate for any determinal environmental consequences of traditional desalination. Thus, the purpose of this study is to investigate the performance of a solar steel in rural regions of Algeria. This is our proposed process of desalination. And using a deep neural network predictive model for solar cell productivity improvements process. Why do we use artificial neural networks in the solar desalination field? Because of complex patterns excelling in nonlinear data analysis, predictive accuracy, high accuracy in solar output modeling, adaptability, adjusts to environmental condition changes, data utilization, process large, differs data sets, operational optimization, enhances efficiency and productivity. Cost effectiveness reduces need for extensive trials, future proofing adapts to evolving renewable technologies. Why can choosing artificial neural networks for predicting solar still distilled water yield be justified despite the availability of simulation software like TNSys and others? Because of adaptability to nonlinear systems, ANNs excel in modeling complex nonlinear relationships prevalent in solar steel performance, potentially outperforming traditional simulations. Data-driven insights, ANNs leverage data to uncover patterns not explicitly in simulation models, ideal for data-rich solar steel systems. Efficiency with large datasets suitable for diverse variables like weather and operational parameters. ANN's efficiency handle extensive data, flexibility, and customization. ANNs can be tailored to specific solar steel characteristics, offering more personalized modeling than generic simulations. uh, Continuous learning and improvements. ANNs evolve with the new data, enhancing predictive accuracy over time, adaptable to environmental and operational changes. Integration with the existing systems, ANNs can seamlessly merge with current monitoring systems, providing real-time insights for solar steel optimization. We have cost effectiveness. Post development ANNs are a budget friendly alternative to specialized simulation software, requiring less computational resources. It's important to note that while ANNs offer many advantages, their effectiveness depends on the quality and quantity of the training data and the skill with which the network is designed and trained. In some cases, a hybrid approach that combines ANNs with traditional simulation methods might provide the best balance of accuracy, reliability, and computational efficiency. For example, the ANN can be used to predict solar energy output based on real-time data, while the simulation model can be used for long-term planning and optimization scenarios. Now we move to the application of machine learning in solar desalination. The methodology of deep neural networks. We have four steps. We have the data collection, data preparation, developments of our deep neural network, and performance evaluation. We start with the data collection. We collect our data from our the solar steel, which is our desalination process. We collect the output is water productivity, and the inputs are the parameter affecting the productivity, weather parameter, and humidity and the wind speed. We have data preparation. We prepare our data. We do data cleaning and feature selection for our model and normalization and data normalization. We have a model development. We choose MLP model to deal with this predictive process. And finally, we have the evaluation metrics. We have four error metrics and coefficient of determination to evaluate the prediction. This is a graphical abstract of our work. We begin with the data collection. We collect our data from our process, which is water desalination. And next, we have data processing. We have data cleaning, batch normalization, data splitting. We split our data between training and test, feature selection. We have model evaluation, which we choose four different optimization algorithms, which is tree structured Parson estimator, Bayesian optimization, grid search, and particle swarm optimization to optimize the hyperparameters of our deep neural network. We have these five error, these five evaluation metrics to performance evaluation and the results. We move to the overview of the optimization methodology that we have made. We start with defining the space, the search space, which is hyper parameters. We have the number of units, the number of hidden layers. We have learning rate and internal optimization and activation function. We choose a search strategy. We have these four optimization algorithms. We train MLP with specific set of hyperparameters, and we evaluate our performance. If our model converges, we stop and test the model. If it's not, we repeat the steps. So our final MLP model uh, is three hidden layers, 64 units for each layer. Activation function ReLU. White's optimizer sigmoid gradient descent. Learning rate is 0.02. Gives with particle swarm optimization. Results. The results of our prediction. The predicted hourly water yield of our process or desalination process as compared to the measured ones are plotted in this figure. The predicted data for soda steel reveals an excellent agreement between the results obtained using PSO as compared to the experimental results in blue. This figure clearly illustrates that the MLP PSO superior performance compared to other models, as evidenced by its lower errors values in MSE, as we see, and MAE, and RMSE. This next figure highlights the superior performance of the MLP PSO model over the models as reflected in its higher coefficient of determination and EVS. We have this QQ plots. MLP models shows closest alignment indicating superior accuracy in this regression line. The coefficient of determination and explain the various score values for the MLP PSO model further substantiate its superior performance with both scores nearly the optimal values of one. We have a radar plot. Each axis represents the different metrics. In case of three error metrics, the further from the center of plot is the higher value for that metric. A smaller area covered by the plot indicates lower error metrics, which is desirable for performance. For the MLP PSO model, the radar plot area is the smallest among all, as we see here, suggesting that it has the lowest value across all the three metrics, thus indicates superior performance. Next, we have in this table a comparison between the present result and other works. We have an excellent accuracy and excellent evaluation metrics. In conclusion, based on these results, it's recommended to use MLP combined PSO optimizer to predict the distilled water amount of solar steel. This is due to the important role of particle swarm optimization to obtain the optimal internal parameters of the MLP model. PSO outperformed other optimizer algorithms and turn optimizers into MLP model. Enhanced the solar cell design insight from the MLP PSO model can inform the design and the modification of new and existing solar cells by understanding the optimal conditions and configurations for maximum yields. Designers and engineers can make informed decisions on materials, absorber design, and other system components. Solar steel optimization, the elevated performance of the MLPPSO model means that existing solar steels can be better optimized, ensuring they operate and their maximum efficiency. Cost saving, the refined accuracy of our model can result in reduced operational costs. Overproduction or underproduction can both be costly. By preempting the expected performance of a solar steel design, a plant can avoid unnecessary expenses related to energy consumption, equipment wear and tear, and resource wastage. Finally, increase the water yield with the goal of a desalination system being the production of clean water. The MLPPSO models application can lead to increased yields. This is paramount, especially in areas facing water shortage. Real-world applicability beyond the realm of theoretical constructs. Our findings have profound real-world implications, especially in enhancing the design efficiency and the productivity of solar cells. The insights gleaned from the MLPSO models, advanced the predictive capabilities, offer a pragmatic path forward for stakeholders in the desalination sectors. Thank you.
Thank you, Mr. Halimi. It was an insightful and comparatively a new domain and where you applied data science and machine learning. Uh, any participant, do we have any questions? Okay, on the contrary, I have some questions, Mr. Halimi. Can you hear me?
Okay.
Yeah,
Yes.
I was curious that what was your motivation behind this work? Because here in India, I have not personally seen many solar stills except some villages maybe. So what was your motivation? Why did you work in this?
Okay. What my motivation in solar steel or what?
Motivation, your motivation behind this work. Why have you worked on this topic only, like
Uh,
predicting the quality of water in solar cells?
yes. We. The main objective is to enhancing the productivity of the solar steel because we here in northern Africa we are in arid zone. So we use the artificial neural network to predict to just predict the output of solar cells, and
Okay,
next we have to optimize the productivity.
okay, okay. And how did you get the data set? Did you make it yourself? Did it have TDS parameter as well in it?
I didn't understand you.
I said that how did you get your data set? How big was it? Data set.
Yeah, yes, from experimental in
You
laboratory.
you okay? You collected your own data set, is it? You
What?
you collected your own data set. I'm saying.
Yes, we have a group of researchers. Some researchers collect the data, and me and others do the
Okay. And how
prediction.
big that data set has become now, Halimi?
It's not a big data set.
Okay, then
I
how will we make sure that the training is correct?
we have the evaluation. We have the validation step. We do the
Okay, okay,
validation. Yeah.
okay. The result that you get through your machine and then actual validation.
Yes.
Yeah, nice. That's a good way. Okay. Okay, that's it from my side. I believe others don't have any question. Thank you for joining us, Mr. Halimi.
Thank you.
Thank you. We'll I like to see you in future conferences as well, please.
Thank you. Thank you very much.
Okay. Now our first presenter has done with his presentation. We have second presentation from Ms. Deepa Naik.
Yes, sir, I am ready.
Yeah,
Shall I present?
yeah. Do you have sharing rights? Presentation sharing rights?
Let me check out, sir.
Okay. By the time
Yeah,
I'll tell your topic to
it
all
is
the
given, sir.
audiences. Yeah,
Yes, sir.
it's optical network, wireless network, hybrid
Actually,
networks.
sir, my topic has been changed. Actually,
Okay,
uh, this was my
not a
topic, sir.
problem.
Okay, sir,
Fine,
no
fine,
issue.
fine. No problem.
My
Okay.
screen is visible, sir.
It is visible.
Yes, sir. Good afternoon to
Yes.
everyone. Today I am here to present my one presentation on quality of service in a wireless networks with the fault tolerance and the efficient bandwidth management. So today I'll be discussing about these contents, that is introduction, literature survey, research problems in this area, and materials and the methodologies what I applied, result, conclusion, and list of references. Usually, why we should study the quality of services in the wireless networks? The issue is that wireless networks are now the integral part of the industry 4.0. Because of that, we are facing lot of issues with the traffic efficiency as well as on the link failures. So in this paper, I worked on the two problems that is related to the efficient bandwidth utilization and the fault recovery of the wireless networks. So first I worked on the fault tolerance, how the fault tolerance occurs in the industry. Like what happens when the particular wireless networks, they are in team, they are in a group and they are connected to the wireless base station through PLCs. There may be due to some fault occurs. That is maybe due to the noise, or there may be some of the multipath dispersal, because wireless, the path is multiple path. They may route on the different paths. Because of that, or there may be some of the noise signals induced, there may be due to this problem there is a noise created. Because of that, wireless network fail to operate properly. For that reason, first we are given a preference for recovering the problem of fault recovery. So in order to recover the problem, I have studied some of the literature survey. But in the previous literature survey, I found that only one part is given more importance, that is bandwidth utilization, proper giving the static bandwidth to the each sensor. There is not, no, most of the work they only concentrated on the bandwidth. Bandwidth is not only the crisis, but there also we need to study the fault occurrence in the particular network. So in order to handle such problems, so uh, I have given, that is how we can handle the particular faults in the network. So main objective behind this fault tolerance is to minimize my bandwidth blocking ratio, efficient routing of the wireless network via some other routes. Like we have maintained one table over here, there are different sensor, temperature sensor, pressure sensor, density sensor, there are multiple. For example, I have taken only three. So most critical is the temperature sensor. What happens if the temperature is unable to sense and send the data to the base station? There is a major problem. In order to route the traffic related to the wires, I've taken the pressure sensor or density server. I've assigned some of the priority for each sensors. So if depending upon the density servers are less active, because of that their bandwidth gets accumulated. Because of that, whatever the temperature sensor failed, the data of the temperature sensor is diverted to density servers. So density server will forward my data to the base station. Because of this, what happens, maybe some few samples of the temperature sensor get lost while taking the longer route, because temperature sensor to the base station is maybe direct path. But when it comes to the density servers, it may be located some far distance from that. But because of that, what happens, there may be a few samples in the temperature getting lost, and it is getting connected to the density server. Density server is having less active, less samples. Because of that, it is having bandwidth. It is able to route the temperature census data to the base station via density servers. So the priority keeps on changing, because we cannot say that density servers is always having the much enough bandwidth and it is able to route the particular sensor. No, this table dynamic, it keeps on changing depending upon the priority. Also get changes depending upon the priority. I check which is the server, which of the wireless sensor is getting fault, and how to route the particular traffic in the different nodes. So the priority of the particular sensor keeps on updating depending upon the time. So we have taken the time samples, and depending upon that, I will route my packet from particular node to the different node. The path may change, the packet may get, few packet may get, but the network will be stable. This is how we can able to achieve the fault tolerance in the network. So once the fault tolerance is up, we have appeared, the next problem is to assign the bandwidth. Usually what happens, we set some of the priorities in the wireless sensor networks, equal priority. Usually in the previous work they have given equal priority to all the sensor, but usually what happens, all the sensors are not active all the time. So I have prioritized the bandwidth and assign the person. If there is 100 mbps of bandwidth, depending upon the priority, I have said that a particular class of bandwidth, if it is not available, the remaining bandwidth can be assigned to the different class who are starving that. But in previous work, what they have done, if it is some bandwidth is left from the first class, they have just equally distributed it to the remaining classes. But I have taken the some classes as well as their latency time in mind, and assigned depending upon the priority as well as their latency time, so that what happens, the equal bandwidth is shared among all the classes. None of the classes are starving. So even though there is a bandwidth crisis, it can be stabilized after some time being. This was achieved using the dynamic. So I prefer that dynamic bandwidth assignment scheme will resolve the problem, and all the traffic can be routed efficiently without any uh, without any crisis. So there is no fault as well as there is no crisis of bandwidth. This was the objective and motivation behind achieving this work. So So, like a particular sensor, if S to Z I want to, there are multiple paths because it is following, it's a wireless network, it follows multiple paths. Among choosing the path also, we should select the optimal path, that is, which leads to less sample loss or less packets on in the network. So we have taken care of that, and also we are checking the priority which is having more bandwidth. Depending upon that, we are selecting the node to forward my packet to the particular sensor node. Here, for example, temperature sensor has failed. I diverted my packets to the density server. So density server will take care of my packets and it will forward it to the base stations. So here almost most of the work they have done, this is only, but dynamic bandwidth assignment policy gives the feasible result. See, in the result we can see that is after some time it is getting stabilized. Even though the bandwidth crisis the lower classes are facing, it getting stabilized after some time T5. But the main one drawback of this is, that is, I conclude the dynamic bandwidth assignment scheme will work fine with while equally giving the priorities without starving any of the classes. But when all the classes are full need of crisis of bandwidth, that time my algorithm is lacking. I need to work, and this work I've kept for a future work, that when all equal bandwidth crisis happens in all the classes, then how to handle that, that will be my future problem. I will be working on that problem in future. These are the references of my work, and this is what I wanted to conclude. Thank you. If any queries, I always welcome you.
Thank you, Deepam, for your presentation. Can you show the slide where you were showing the placement of the sensor? I have some questions there.
Placement of a sensors.
Yeah, there was a network where the sensors and things were placed.
Wait a minute, just a minute. Yes, sir.
Yeah, there. So, can you tell me that where are the sensors and where are the device which the sensors are sensing? Which one of them are those?
Look, sir, all are the sensor. S, D, A, C, D, Z, all are
All of them.
sensors.
Okay.
All are sensors.
And
but
where they
what
are supposed to be placed? Yeah.
Sir, it cannot take the route S to A because this is having a pressure sensor. It is usually what happens, it is very active and its sample rates are high. It is having crisis of bandwidth. That's why it is taken this path. B.
Mhm.
Then it has D. It cannot travel to D, but it is taking this path. Like means we
Okay.
wanted to prioritize the sensors depending upon their sample values.
But ma'am, these sensors are sensing the health of the network, right? The vitals of the network.
Yes, yes, yes.
So where these sensors will be placed near the network, and the network itself, you said, is wireless network.
Yes, yes. Network
So
itself is wireless.
is a wireless network. So the wireless networks, for example, there is a host and he is moving here and there. So how will we like place the sensor near him, or are we just planning to place the sensor near the static routers?
Actually, sir, it is implemented in the plant. So the place is fixed for the sensor. They are connected wirelessly.
Okay, okay. So, and which protocol do you propose we should use in transport layer, application layer, etc. for this protocol?
Sir, here I used the TCP because I need acknowledgement for this.
Okay. But why do we need acknowledgement? It's a small message that we are sending from the sensor,
Yes,
right?
but I wanted to check the first message should be relevant. That is whether the particular density server is taking my request or not. There may be a chance that I am sending it, it may not respond. For first time, I
Okay.
used the
Only
TCP
once.
only once. After that,
So
once I get
it's
the
a kind of a
acknowledgement.
dialogue exchange, right?
Yes, 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 sir.
Okay. And in the this application layer, are we using application layer protocol like SNMP or something?
Simple mail transfer protocol I have not
No,
implemented.
I was talking about SNMP, simple network management protocol.
No, I have not
SNMP.
used here.
Not
Sir,
using
here,
it.
here I have not used. But I am for another work I used that one.
Okay.
For
Okay.
sending the alert signals, I use that one.
Because it's already in place and it is meant to check the health and vital of all the network backbone devices that we have. So I will like recommend you can use it here as well.
Huh. Okay, sir.
Okay.
Let me implement, sir, that one over here. Currently, I gave only two objectives. One is to dynamically allocate the bandwidth and to recover the faults.
Okay.
Okay, sir.
So
That is our good work.
bandwidth
Okay,
will be
sir.
reduced if we detect some bad things happening, right?
Yes, sir.
Okay. You were saying something. Sorry, I interrupted you.
No, sir. No, it was a good suggestion. I was telling that, okay, sir, that let me apply that one in future work.
Yes, ma'am. Thank you. Thank you for your presentation, ma'am. Thank you for accepting the invite and giving your paper. It will be a valuable addition to our journal.
Thank you so much,
Thank you.
sir.
Thanks a lot.
It's my pleasure. I would like to come in future conferences also, sir. Thank you so
Sure,
much.
we are trying to plan something much bigger. If for the next time, definitely we'll invite you.
Okay,
Thank you,
sir.
ma'am.
Thank you, sir.
So this session of presentation comes to an end. We are actually over a little bit early, but still it's okay. We'll enjoy a bigger lunch, with more time. So we'll meet again by. I'll tell you the time. By 2 o'clock, we'll meet again for the next round of presentations. So I'll request all the participants as well as the audiences to join again. The lunch will start from now till 2 o'clock. And by the time we'll meet again with two more presenters. And then I'll request all of you to join the valedictory session. Whoever can come, those who are online and away from India, I cannot say, but those who are there in Jabalpur, in the city we request you to join. You have time to come here. Thank you. Thanks a lot.
Thank you. Thank you very much.
Thank you so much, sir, for your valuable comments.